our goal is to make Kubernetes more usable through focusing on things like user experience, accessibility, internationalization, all kinds of concerns that easily fall through the cracks. I'm stealing this slide from Tasha's introduction the other day because I think it hit quite close to home. The project has suffered pretty badly from something called Conway's Law, which is that the organizational structure of everybody building a thing tends to inform how the thing is built. And as a result, the user experience in Kubernetes tends to be somewhat sharp in a lot of areas. So we're a new SIG. We were formed a couple months ago. So at this point, we're still finding our feet a little bit, especially as a horizontal SIG, because we don't directly own components, we more own concepts, and we work with other SIGs to make sure those concepts are applied. Right now, there's a couple different projects that we're working on, in particular trying to do more user research to figure out what people are trying to do, how they're experiencing things, and what they need, and to better bring that into how we build things, because it's very easy to build beautiful machines or things that solve the use case that we think exists, but it's harder to actually make sure that we build what works for everyone. So in particular today, I am more of an engineer than a product person. I'm going to particularly talk about trying to change some of the default settings in Kubernetes around security so that it's less of a sharp edges, nasty surprise for people using it. So in particular, I'm going to talk about network policy, how to change that, and a little bit about pod security policy. So lots and lots of people actually don't use these with production workloads. I won't ask for a raise of hands because that might be embarrassing, but it's very, very common, and these are actually very important resources. So firstly, network policy. In Kubernetes, we have a lot of network abstractions that we leverage very heavily. We don't, in most cases, tend to think about the individual pod IP and discovery because we just use something called the service. So services expose nice little short, convenient DNS names within their namespace. So you get to say like, connect to Redis or connect to HTTP Nginx. And as a result of that, we tend to automatically assume that these are only available within the namespace we're in, that our services are nicely protected like that and something outside the namespace can't get in. But that's not quite accurate. So any two pods in Kubernetes need a CNI driver, it's called, to connect to one another. If you just spin up a cluster on bare metal, like I have before, you don't install a driver by accident, you can't actually use the network. It's a surprising frustration. So you use something like Calico or Flannel or like a cloud provider specific driver in order to make sure that everything gets an IP and that there's some kind of rules, be it like IP tables rules or cloud rules or Cilium, managing eBPF or something to actually connect two things together. So in reality, this is the default network grid if we just spin up a cluster and put some workloads in it. Everything can talk to everything else. You have to be able to figure out IPs or guess addresses, but it's all there. It's totally unrestricted. So who's surprised by this? At least one hand. I will admit I was using Kubernetes in production well before I learned about this behavior. And that's a very common thing because I will fully admit, like to go into Stack Overflow or quickly copy paste something with the docs, and we don't tend to realize the full implications of how the nitty-gritty machinery works. And that's what ideally we should change because the path of least resistance should be a better path. So the network policy is an object that specifically lets you put restrictions on this. It tells the CNI driver which routes it should actually allow versus which it shouldn't. So at some kind of firewall level, again, be it like cloud stuff or IP tables or whatever, there will not be rules put in place to connect two given pods if your policies don't allow it. So the way that the network policy works semantically is the default behavior falls open, right? If you have no network policy, everything can talk to everything. But network policies, as soon as they apply to pods, it becomes an instant lockdown. So even if you just touch a pod with a policy and specify no rules, it can now do nothing. And at that point on, it's a whitelist of adding increasing rules to to let it do or let other things do more and more things. So here's a fairly typical example. Forgive the YAML, I know it's a usability talk. Taking a specific label on pods in a specific namespace and then saying, hey, you get ingress to this. So in particular, for the label B, pods A in namespace with team A can connect. So this is like a way of saying, your workers can access my cache or something, and nothing else can access this. The label semantics, if you're not familiar, is a super, super common pattern in Kubernetes for specifying the relationships between things. App is also just a very common convention. It's not actually meaningful. Resources get individual key value labels, and then when we want to match something up, we specify a label match. So if I want to like point out in a policy a particular set of pods, I'd say like service X or app Y or whatever the label is to specify all pods in that like high-level deployment/service. So this is actually what that looks like. This is a much more reasonable graph of network access. Pretend that there's probably lots of other random things in there, but it's not everything to everything anymore. It's now exactly what we need. So let's change this, right? We want to make this better. We want to make this something that's easy to do and users are actually funneled into versus something that users have to read the I don't know how many pages of Kubernetes docs to figure out, because I'll fully own I'm a bad user of software. If I'm just trying to set up a database or something, I will go in and try to take the quickest path. I don't do that with Kubernetes, but that's because I'm a Kubernetes developer. I'm an expert in it. And I take the time and I understand it. I certainly am unhappy when developers expect me to have a deep, deep knowledge of any product in order to use it successfully. And I realize that people will have the same expectation for me of things like Kubernetes that I work on. So we should change this. We should make it explicitly more closed and give users the kind of danger button escape route of, okay, I'm going to make it unrestricted just because it's better for my use case, and I have signed to the metaphorical NDA and have acknowledged the risks. The obvious question is, why isn't it like this already? And it's a nasty question that I've been grappling with lately. The three biggest answers are compatibility with existing systems, because you may have heard Kubernetes is a thing now. People use it in production. It's past version 1. We have specific guarantees around compatibility. The next one is support. We don't actually, in Kubernetes, make a CNA driver. We actually kind of do, but we're actively deprecating it. It's that we maintain a spec that then other companies or third parties write things for. So the network policy right now is an optional thing. There's a specific spec for the CNI where you have to be matching a certain set of APIs to be compliant, but network policy is deliberately something flexible because how you want to manage your network is a super complex and opinionated topic. And to an extent now, and certainly at the time this was created, we didn't want to lock ourselves in and lock everyone into a hyper-opinionated model. It's kind of the ethos of Kubernetes. We let people build whatever they want. And the last one is just convenience. For better or for worse, there was a choice made that we want the kind of Kubernetes up and running hello world path to be as simple as possible. And having to configure 4 more pieces of YAML to get your demo app going is pretty frustrating. So I was one of the people who was somewhat involved in the process to remove some APIs in the release before last. I was more doing like the PR side than actually doing the implementation. Who's heard about this? So I failed. So this is, I believe, the first time in GA Kubernetes that we've actually deliberately really broken APIs. Basically, there were a couple things where we either wanted to move them around semantically, so the resources existed but just different path, or we were finally retiring old versions of things that we just wanted to axe because people should be using the new thing. So these things were deprecated for multiple years. You get warnings, it's in all the release notes, and then 1.16 comes out. So we delete them, We hammer out with blog entries. People are mentioning it on all like their individual talks and live streams. People are tweeting about it. It's in all the release notes over and over and over. And then it's so sad. I load up Twitter when it's released and everyone's going, 116 broke my cluster, because people didn't know. We knew it was going to be bad, but we didn't realize how bad it was going to be, because the reality is, number one, people just aren't super engaged and aren't reading these things, which I guess shouldn't be a surprise, because Kubernetes isn't meant to be super exciting. It's meant to just be a detail to make your stuff run that you do care about. And the other thing is, people who were fully aware that this was happening still were unaware of some dependency they had. They would get shocked because their Jenkins installer or Jenkins manager relied on some of these APIs to deploy. And even though they thought they had updated everything, they hadn't. So this is a long story, but the point is, it's taught us in a very real way about the caution about we need to have around making breaking changes, even if we follow all policy and do it to the letter, because it's still really rough. Now the question is, how do we introduce a new default without just saying, hey, 118, everything's going to break? It needs to start opt-in in some way. There's lots of ways we can introduce behavior like new CLI flags or some kind of cluster config or new resource versions. And there's no we actually have like a very well-outlined document for Kubernetes. I forget the name. If you Google like Kubernetes deprecation policy, you'll find it around what kind of breaking changes we can make, what we can't, and how long we have to give people notice for around different things like admin CLIs versus user CLIs versus APIs and all those things. And lastly, there's no letter of the law that says that it should be easy to migrate this, but it really ought to. Python 2 to Python 3 is a big example that people bring up, because that was a bumpy migration. And as a result, people are still running Python 2. And people are going to be running it past end of life because it was hard to change and they just want their stuff to work. So the kind of obvious thing that comes to mind is we're changing the way network policy works. Maybe we just bump the network policy resource. But unfortunately, it doesn't quite work like that, because we're not changing the way a network policy works. We're changing what happens in the absence of a network policy if we want to make the network fail closed. So network policy v2 wouldn't mean anything, because it would fundamentally mean if you just deploy stuff with no network policy, the behavior's changed. It's kind of interesting because it's like not the API guarantee, it's the semantic guarantee of what a resource means. So the idea that was brought up when I raised a KEP, which is our semi-formal, formal process for making notable changes in Kubernetes, is the idea of having a namespace v2. So specifically, we have processes to sometimes create resources on certain hooks. Like if you create a namespace, we create a default service account and a default token. If you've ever seen that or used that, you'll notice that you didn't have to do that. It gets created on namespace. So what we thought about is the idea of having a namespace v2 that will automatically create a network policy that touches everything, says everything's fully locked down. So that way we're maintaining the semantics. If you delete that network policy because you don't want it there, everything behaves as you expected. And if you add more policies to it, then you're explicitly adding whitelists as expected. So this is a way that isn't breaking any guarantees. And also because we deliberately make sure that things like tooling like kubectl biases towards new APIs, it's a way to default on-ramp people onto this. So they don't necessarily have to aggressively opt in. We just catch the people who don't care, they just are going the default route. And people who specifically have a huge problem with this or have compatibility guarantees can deliberately use namespace v1 and avoid this behavior until they're ready to change over. There's additional fun as well, like Kubernetes Conformance, because this is the kind of thing where it would be so easy if this had been thought about like 4 or 5 years ago, or more in reality, if it was a big enough priority 4 or 5 years ago, because there were many decisions that were deferred. Kubernetes has to pass a conformance suite, it's called, of end-to-end tests to be considered compatible. So this is why we get things like Azure Kubernetes Engine and DigitalOcean Kubernetes and all these like something Kubernetes. It's because they pass the Conformance suite and behave like a standard Kubernetes distro that we can swap between. So this test set is quite complicated, and we need to make substantial changes to it, especially in the face of any vendor opinionation. And the last big issue is just the user experience part. It's like a classic complaint, Kubernetes has too much YAML. I recently spoke with someone who used to work with Tupperware, a Facebook product, and their big complaint was that they used to be able to have, Tupperware was kind of like the Borg or the Kubernetes of Facebook. So their complaint was, I used to have one struct I would write out, now there's like 2 structs I have to write out bare minimum for a service, often like 8. So it's more friction for users if they have to set up yet another thing to get working. And forcing more people into network policy will also just expose more of the sharp edges of it. We know it's not a perfect spec, and some people deliberately avoid it because of that. So if we make everyone use it, we may want to think even about polishing it and having a V2 of just different feature set before we do that. Somewhat notably, Istio made this design choice. So network is default restricted, or at least was, I think they might have changed it, unless you explicitly add an allowance. And that really bothered people because of that friction. So it's not just theoretical. We've seen in the space, people don't like having a lockdown network. So in a bit less detail, I want to talk about pod security policies. I jump around in a lot of SIG. SIG network's kind of my home, so I focus on the network policy. But pod security policies are very, very high impact. So again, maybe a mental show of hands if you don't want to embarrass yourself. Who hasn't heard of this? Yeah, cool. So it's okay, you're one of like lucky 10,000 people who are going to learn something new today. You're going to learn something really important. Pod security policies restrict what pods can do by specifically restricting what details of pods you can create. So they're not an enforcement mechanism for pod behavior, they're an enforcement mechanism for pod specs. It's basically a set of rules that says you cannot do certain things, such as you can only mount these volumes, or you can only act as these SE Linux groups. And if a pod has something in its spec that violates this, then it just can't be created. You get like an API error. So if you're not using pod security policies, or some equivalent thereof, like for example, the OPA is something that provides equivalent functionality and much more granularity, then your cluster can get totally taken over probably. So this is a scary thing. I learned this a number of years back when I was trying to set up Jenkins builds on Kubernetes. And I was all excited because it was going to be so resource perfect. And this was back in the days where like Docker and Docker for building meant actually having to give stuff fundamentally root access. So it's like, hey, if you can make a Jenkins job, then you can create pods, which means that you can use this escape hatch and take over the build cluster. Fun. So that's why that project failed. Simplest example is privileged containers. Privileged containers can get fundamentally root access on the cluster. It's meant to be a very strong escape hatch for if you have to deal with like specialized hardware or something that you can't easily privilege the containers to do at like a fine-grained level. So if you specify in your pod security policy that privilege is false for a set of pods, then if you try to create a pod with the like privileged true security spec, you can't, you get denied. So this is one way where an attacker is blocked off. Again, like the good news about this is you do need the ability to create or potentially modify pods in order to do this kind of attack, but typically like you have a lot of machinery and a lot of developers who can do that. Slightly more complex and sometimes more subtle example is volume mounting. So here on the left, we have a spec that lets us mount pretty much the minimal set of volumes for a normal pod to go. It's all like the meta stuff, like the ability to mount config maps and secrets that are part of just often setting up a pod, plus assuming that any persistent volume set up are safe. So this means If someone nasty tries to set /proc or etc password as their volume, they can't do it. Without this, what I could do is I could make a pod spec that says, I'm going to mount in etc password into my container. Now I connect to my container and go, I'm going to add a user. I'm going to add a Vallery, and it's got sudo. And now suddenly, I have the ability to get sudo on the host. Really, really bad stuff. So again, this has similar problems with trying to push it forward to network policy. Making a change, it's frustrating, and there's some additional questions floating around. In reality, changing this would probably require a pod v2. That's kind of unfortunate because that would mean actually a v2 of probably like the core API group. And that would functionally be Kubernetes v2. I'm sure we're going to hear about the 2.0 release one day, but it might be a longer road to that. I've spoken a bit with people from SIG Auth who actually maintain these components, and there's also some uncertainty about the future of is pod security policy going to be the way to go forward. They're actually doing a talk. They're doing a talk tomorrow, which I'm told will cover it. I don't have any guarantees on that. Because pod security policy is just a very opinionated admission controller, admission hooks are something we have where you can validate or change things as they're applied to the cluster. So it may be, pod security policy may be a built-in concept, but it's using a very generic thing that anyone can work with. And in fact, anyone has, because we have things like the OPA and Gatekeeper that are frameworks built upon that to specify very advanced and granular rules. So instead of having like 15 different options with lists or toggles saying I want to allow this or don't want to allow this, people are building all kinds of customized things or even just letting like individual companies write their own rules in a trivial fashion. So there's a reasonable chance that we're going to want to move forward in that direction versus specifically using the pod security policy. Again, that bias towards configuration over opinionation. A lot of these concerns are things where it would have been easy to design it right, or at least not as hard as it is now, but now it's hard to change. And the good news is it's no longer a hack to get Kubernetes out the door so we beat Mesos. We're here, we're at KubeCon, we've arrived. So now the standard is way higher for actually building things. And now we have things like SIG Usability trying to work on these problems. I'm also part of a SIG architecture effort to have a public readiness review process. And a lot of it is going to be, are we making a default that isn't ideal that we're going to get locked into? Because while these things are possible to change and there's a non-zero chance they will change, it's a huge uphill battle to do so because change is hard for running software. It's expensive to design things the wrong way. And that's why we really want to focus going forward on making sure we do things the right way to alleviate that cost in terms of the development effort and the downstream user pain in the future. So if you want to get involved in the SIG, there's a couple different things going on right now. The majority of it is more user research focused. This is kind of a smaller thing within the SIG that I wanted to highlight because this is where like Kubernetes devs come. In particular, studying user studies, trying to build profiles, doing like a jobs to be done survey around what are the specific tasks people use with Kubernetes, as well as things like out-of-the-box behavior that I'm working on. There's some documentation work, and then there's kind of more ad hoc collaboration with individual KEPs and things like the SIG Arch PRR of how do we design the right thing now that we're here. So if you want to find more about SIG Usability, we have a page in the like standard GitHub repo for Kubernetes community stuff. If you also just Google Kubernetes SIG Usability, you'll find us. There's a page with a whole bunch of stuff there. The kind of main details to know is joining the Slack and joining the mailing list. So the mailing list is probably where most communication happens. We also have like every 3 weeks a community call to kind of sync up on things. But otherwise, yeah, pop into Slack, pop into the mailing list, watch what's going on. If you have questions, ask them. Because this isn't a feature thing, this is a make Kubernetes good thing. So it's hard to get people who are being paid to work on it, because everyone wants their new feature out the door, but as long as Kubernetes mostly manages to roll along, things like usability and scalability and security are often a little bit less focused on. So if you have the ability to help out, that would be greatly impactful. That's all I have. I can take some questions if folks have them. Yeah. If you shout it to me, I can also repeat it. So the question is on enforcement versus visibility, with a couple examples around like exposing information in kubectl that something is maybe not ideal. It's something we have thought a bit about. I think it needs to be a two-pronged approach. Enforcement is far more complete because we have multiple ways of interacting with Kubernetes. Technically, it all goes through the API, but like a lot of people only ever experience kubectl apply and kubectl delete in Kubernetes. Like they set up a Jenkins thing, and the Jenkins thing is just kubectl apply my YAML. So kubectl is a pretty good start, but there's a long tail of people who are using some tool where they're either using kubectl and not seeing the output, or they're using a thing that's calling the API, and that thing, like if they're using a Jenkins integration, might never surface the details. I think the 116 breaking changes taught us that we do need to surface these things more visibly, though. Like, kubectl will warn you if you are creating a new resource with a deprecated API. But maybe it should just warn you whenever you look at that. Or maybe even when you look at like something adjacent to it, like the service that's attached to the pods that match the deployment. That could get messy, but the more visible we make things, then the easier we are equipping users to make the right thing. Yeah, we had a couple of conversations around novel ways to address that, but I think that definitely exposing that in some format could be ideal. Like maybe even longer term, we could have something in status with just warnings. Again, super hypothetical. I'm sure it would take a lot of bike shedding to come up with the right solution, but making sure that just generically the information is exposed and either enforce with tools we control or trust with tools that are third party that information will bubble up somehow to the user. Thank you, that is a good point. And I'm curious about some of those specific proposals. Any other questions? Otherwise we can get 6 minutes of our lives back. It's more in the stages of actually building out the survey, but I can connect you with the people who are leading that effort if you're curious more about it. Yeah.
So you mentioned this, for one of your slides, you mentioned the idea of like how to introduce this person to network policies or ways to turn on. Like, you know, it sounds like a good idea. So in another effort to make this like, you know, like having nested how, I mean, you're coming up with kind of one idea for they can for what they want to do. How do these like how do these things kind of work? I could, we have a usability issue here. I can see if that kind of gives you way of like.
So the question is on nested namespaces. Just, is that the multi-tenancy nested namespaces, or is this something different?
I think it's multi-tenancy. What's what else?
Yeah, I'm not super sure of the issues offhand, but one of our co-chairs for the SIG is Tasha Drew, who's multi-tenancy lead. So I'll check with her and see what kind of big going concerns there would be. But at this point, I think like the bigger blockers are working with the constituent SIGs to see if they'd want the change to happen, period, versus just the mechanics of it. All right, last call. Okay, thank you everyone for coming.